Good afternoon, everyone. We'll give it a couple minutes for people to join and then we'll get started. All right, let's go ahead and get started. Good afternoon and welcome to the fourth and final session of the AI Virginia's Building Reuse and Decarbonization webinar series, presented by AI Virginia's Historic Resources Committee and the Virginia Committee on the Environment. My name is Delaney Ogden. I'm the Director of Education for AI Virginia, and I'm the host helping with the webinar today. And I've got a few housekeeping items before we get started. We'll have the chat feature available to you today, so please feel free to engage with others while you're on the webinar. We'll also have a Q&A portion at the end of the presentation, so please make sure to use that tool whenever we get to the Q&A part. Put your questions in that feature. And then if you're having any connection challenges, please make sure to remain on Zoom. Zoom does a really great job of reconnecting you automatically if you do have connection challenges. I will be sending out a survey after the session, so please take a few minutes to complete that survey. We'd love to hear your feedback. The session today has been approved for 1.5 LUHSWs, and the credits will be reported within 10 business days after this presentation. And as I mentioned, we'll have a short Q&A period after the presentation. I'll turn it over now to Andrew McKinley for a few comments.
Hey everybody, thank you Delaney. The AIA Virginia Historic Resources Committee and Committee on the Environment are pleased to host you for Building Reuse and Decarbonization webinar series. These two committees have collaborated to bring you a four-part series, of which we are witnessing the fourth of our four parts, showcasing overlaps between historic preservation and sustainability to advance carbon footprint reduction. The building industry is known as one of the largest producers of carbon emissions, and by adapting existing buildings to support contemporary needs rather than demolishing buildings, we can avoid emitting thousands of tons of carbon into the atmosphere. With the growing shift towards renovation over new construction, this webinar series shows how the renewal of existing buildings as high-performance facilities creates a sustainable and resilient world. The series brings together leading experts in architecture, interior design, sustainability, and electrical engineering. Our presenter today is Denise Gravel. Denise is an architect and sustainability specialist at Quinn Evans in their Washington, D.C. office. She's knowledgeable in life cycle assessment calculations and embodied carbon research, having helped to develop Kaleidoscope, an early embodied carbon assessment tool. Denise has experience with a variety of existing building retrofits, including laboratory and education spaces, and a historic elementary school in Washington, D.C. Please feel free to place your questions in the chat throughout the presentations. I'll gather them and hold them till the end, where we will get to have a conversation with Denise and grill her on all things carbon. Without further ado, please welcome her as presenter of our fourth installment for this presentation titled Carbon Counts, Quantifying the Value of Existing Building Stewardship. Thank you, Denise.
Super. Thank you, Andrew and Delaney. I'm really happy to be presenting here for the final installment in this series. And if you've attended some of the other ones, I hope there's some overlap. And actually, there'll be some sort of full circle moments today. If you attended the first one, my colleague Sarah Langmead presented some introductory remarks on some things that I'll be expanding on today. So um, if you're at that one, now you kind of get to see the full picture of what we were talking about. So just a quick intro. I think Andrew covered most of it. So I am an architect and sustainability specialist. So here at Quinn Evans, I have a sort of unique role where I do, roughly 50% of my time is project work, but 50% of my time is dedicated sustainability work. So sometimes that means helping projects in pursuit of sustainability goals, but sometimes that means in-house sustainability initiatives or other things of that nature. And so we'll get into some of what that looks like today with some fun bonus stuff at the end of the presentation. So stick around for that. Um, but for the most of it, this is what we'll be talking about. So here are our learning objectives for today. Um, Upon completion of this presentation, you'll be able to identify the impacts of climate change and the role that existing buildings play to minimize these impacts. Summarize how existing buildings can be retrofitted to reduce the environmental impacts of both building construction and operations. Explore simple tools to make early design decisions and quickly quantify existing embodied carbon and avoidance of additional emissions through the reuse and retrofit of existing buildings. And finally, identify opportunities that existing buildings present for carbon reductions in the built environment. So I'd just like to start with a little bit of level setting before we get into the real data heavy section of the presentation. So why are we talking existing buildings? If you've attended any other presentations by Quinn Evans, we are always using the phrase, the greenest building is the one that already exists. Carl Elefante sort of coined that phrase, and it is kind of one of our core ethos principles here at Quinn Evans. So, um, but what does that really mean? So why do we care about building reuse? So there's a number of reasons that existing buildings are great, and I probably don't need to convince you all attending the presentation today on this, but here are sort of the top five in my perspective. So the first is being historic buildings with defined value. Historic properties typically have sort of set parameters for what makes them a historic project and can qualify for historic tax credits and things of that nature. The second being the sort of business case from an architecture practice perspective. We are invested in making existing buildings better, and that's part of what keeps our doors open and what the type of work that we do is. And that's another big thing that we do here at Quinn Evans. The third is the cost benefit, the for the actual client or the owner of the building, and we'll get into that. Um, Fourth is the ties to people and place. So um, this is probably the most important for the sort of user perspective. Existing buildings really connect people to a certain place, or they, hold memories, and there's a lot of importance there from a human perspective. And then finally, environmental stewardship. And so that's most of what is the tie to carbon and what this presentation is about today. But I think all of these things are really important. And it's an important perspective to keep. So when we're talking about the sort of historic designation, this is a great example of one. The American Brewery in Baltimore, Maryland. Again, my colleague Sarah spoke to this one at length in the first presentation. But this is a project that took an abandoned brewery in a depressed neighborhood in East Baltimore and transformed it into the headquarters of a nonprofit that serves the local community and promotes employment. And this is one where it'd be a real shame to tear it down. It's such a beautiful building, and the character of it is really what um, makes it of value to the community and the primary reason that the building was saved. With regards to the business case, this is a snapshot from the 2022 Architectural Buildings Index, which showed that work on existing buildings accounted for more than half of all firm billings in that year. And that trend continues to rise. As we see existing building stock aging in place, it's really um, our goal and our objective as architects to take those and transform them into new and better performing buildings into the future. 90% of the buildings that we use today were built more than 10 years ago. So we really need to make all those buildings sustainable in addition to the sort of new construction that we're doing. So there's a huge opportunity for impact in the architecture industry if we focus on those existing buildings and start to claim that. So with regards to cost benefit of projects, it's not always the case, but sometimes it is the case that existing buildings are cheaper to renovate than building new. Um, this example on the screen is Allegan District Library in Michigan. This is a building from the Carnegie Library's building line. And on the right-hand side is the historic building, the sort of original at the point of construction. And then on the left-hand side is the addition. And the cost per square foot for the renovation was actually cheaper than the new addition to the building. So sometimes it is of cost benefit to our clients to renovate existing buildings and take advantage of existing building stock instead of building new or demolishing and building new in place. Um, and then ties to people in place. This is a Quinn Evans project that's gotten a lot of screen time lately, a lot of press attention because it's an icon in Detroit. Michigan Central Station is a huge building. It's a landmark, and it's been a labor of love in our office for many years now. Now that it's finally open, it's really amazing to hear the stories that people have of the historic building, um, and it's like truly iconic. And so many people have uh, come to the table with stories about, their experiences with Michigan Central Station before it fell into a state of disrepair, and now seeing it with a new life to the building. It's really been a fabulous experience. Misordered my slides there. And then finally, environmental stewardship. So um, often preservation of existing buildings can seem sort of incompatible with sustainable design. And often when we think of sustainable design, we think of these sort of like light wood pavilion buildings, maybe, located in a landscape in which there's opportunities for things like rainwater harvesting and bringing landscape elements in, and it's net zero, and there's solar panels everywhere. And yes, all of those things are good, but I am here to make the argument that sometimes taking these existing buildings and preserving them in place, it's actually a better thing from a sustainability perspective than demolishing and building in one of these like new construction projects instead. This is one example of which the National Zoo, the Birdhouse project that we completed here in DC. It is an existing building that we retrofitted and made more high performing, and it eliminates the need to demolish existing buildings in place and sort of reuse the carbon in the infrastructure. So, all right. So with that sort of as my prelude, now I'll get into what I like to call Carbon 101. And this is really hopefully remedial information for a lot of folks. If you've learned anything about embodied carbon, this is probably not new, but it's always nice to be on the same page about what that means. So, as Andrew alluded to at the beginning of the presentation, we know that carbon emissions are strongly skewed towards the built environment. So buildings and operations and building materials and construction um, are nearly 40% of all carbon emissions globally, right? You could argue that transportation and industry have something to play with that too, but just for the sake of our case, we're going to focus on these pieces of the pie. So yes, this does mean that buildings are the problem. However, this also means buildings can be part of the solution. If we can drive down those pieces of the pie and shrink the amount of carbon emissions that the architecture industry is, responsible for, then we have a real opportunity here. So when we focus on the building operations piece, this is anything that it takes to keep a building running. It's what, the powering the HVAC, the lighting, elevators, you name it, anything sort of like plug loads of the building. This is all the building operation emissions. And we've gotten pretty good at, you know, we've gotten pretty good with the metrics associated with building operations, right? Everyone's familiar with EUI today, and you can say, okay, my building has an EUI of 30, and we know that's pretty good compared to an EUI of 120 or something of that nature. These are metrics that we're roughly, comfortable with as an industry, and we've gotten pretty good about um, improving operational emissions. But then there's this piece of the pie, the building materials and construction. So this is your embodied carbon piece. And yes, we are more familiar with what that means now as an industry. We haven't gotten very good about reducing that yet. And part of that's because I think we don't necessarily have a good sense for what it is. It's sort of this ambiguous thing, and it's a tricky thing to understand. So if we zoom in particularly on that little slice of the pie, and if we expand that out, this is data from the Carbon Leadership Forum. And this is sort of an average industry-wide. This varies widely building to building where the embodied carbon is found. But at large, you can see that the structure, the MEP, the envelope, and the finishes are the things that are really driving embodied carbon emissions. All the other things are sort of smaller pieces of the pie. With reference to existing buildings, what are the things that remain in place when we renovate existing buildings? Well, namely the structure and the envelope. We're often replacing the finishes and the MEP when we do renovations, but the largest pieces of the pie are things that are generally going to stay in place when we're renovating existing buildings. And so it's really important in this case to maintain existing building stock instead of demolishing them and emitting more carbon via the construction of things like structure and envelope. And the materials that go into these that are the heaviest carbon emitters are going to be things like concrete and steel and glass. So that's why these things are really driving embodied carbon emissions. So I always like to show this image because this is really what we're thinking about and what we're sort of after when we think about embodied carbon calculations. We're basically taking inventory of everything that goes into the building and calculating the amount of carbon that it takes to produce each and every element of the building. And so this is sort of the example of that case, right? But then if we multiply that out to sort of a city scale, it's a lot of stuff. There's just a lot of embodied carbon that's in our cities and our existing infrastructure. And the statistic is that embodied carbon will make up almost half the emissions associated with new construction between 2020 and 2050. So, like I showed earlier, as building operations are made more energy efficient, the relative importance of embodied carbon will only increase. And there's sort of a timeliness factor to this. So, just for a simple little exercise here, this chart illustrates carbon emissions over time. So the x-axis is years, the y-axis is total carbon. And if in this case, so this line here is an existing building doing nothing. So the line starts at 0 because we're not emitting more carbon with the construction of a new building. And the slope is the amount of operational emissions over time. So each year it's emitting more carbon um, just via the operational emissions. Compare that then to a new building. So that line jumps up at 0 to above the 10 mark. So that's the embodied carbon that it takes to construct that building. And let's say that it's more efficient than that existing building. So that's why the slope of the line is not as steep as the existing building case because it is more energy efficient. So over time, it's still compounding and adding to the total carbon emissions. But that first jump up at 0 because of the embodied carbon emissions is what's making this one look higher than the existing building case. The dashed line is in a decarbonized grid scenario, and this is just to illustrate that, over time, hopefully as we transition to clean energy, if you have an electrified building and you're using clean energy exclusively, over time, the carbon emissions will zero out because if your source of energy is clean, you're not contributing to carbon emissions. So that's sort of a little caveat when it comes to new buildings and higher performance. Okay, now let's compare that to a new net zero energy building. So if that new building, again, jumps up at 0 to the same line as the new building, but if it's net zero from day one and its operations are clean, then it's not adding more over time. So that's great. We love to see that. But what if we really push the envelope here? What if we did a high performance retrofit to an existing building? So now, if we renovate an existing building, but we're maintaining most of the embodied carbon, sort of. So at 0, it's jumping up a little bit, not as high as the new building case, and it's still contributing to carbon emissions over time. That's a slightly shallower slope than the new building case. And then again, showing that dashed line, indicating what it would look like in a decarbonized grid scenario. And then that's sort of my case for existing buildings. So after 30 years of performance, that high performance retrofit is just catching up to that net zero energy building. So it's got a long runway before it's really catching up to emissions of the new building cases. But now let's think hypothetically, what can we do even better beyond that? Well, let's say a net zero energy retrofit to an existing building. Is that possible? Well, yes, we're seeing it a lot. Um, well, I wouldn't say a lot. We're seeing it every once in a while. This is a project that's near and dear to my heart. This is a elementary school here in Washington, D.C., and it is going to be a net zero ready upon completion. And it's a retrofit and addition to an existing building. So on the far left of the screen is the historic portion of the school, and on the right is the new building, and it's designed. It'll be an all-electric building, and it will be net zero offset with solar panels on the roof of both the existing and the new building, and on site to offset the annual emissions of the building, making it net zero. And we're very excited to see this one open its doors in the next 2 years. So um, that's going to be very exciting. So hopefully we'll see this trend continue and more net zero energy retrofits. So the title of this presentation is Carbon Counts, and I want to get into the counting part of the carbon. So how do we quantify our impact? So at Quinn Evans, we're always asking these kind of questions. How do we measure and communicate carbon both internally and externally? how do we really quantify transformation, and how do we communicate and measure the value of reuse of existing buildings? Again, it's sort of this ambiguous thing, and carbon isn't something that you can tangibly touch or quantify in the same way that we understand EUI, right? Um, and we also want to encourage creativity and innovation in the way that we're thinking about carbon. So one of the tools that we use to do this, and I think it's pretty novel. Um, every year, we collect project data on all of our projects, company-wide, and we capture little snippets of information. So we're both capturing sort of quantitative, but also qualitative data. We want to know the numbers of how our buildings are performing, what's the EUI, how much carbon are we avoiding through building reuse, but also what are the stories that we're telling through the project? What sort of cool sustainability aspects are there? What are sort of the wins that we've had on the client side? And so these little project story forms, if you will, are a way that we can capture that information on all of our projects company wide and report out on that year to year. And the way that we collect the quantitative data is through a series of tools, really. There's not one tool that's sort of the end all be all. There's no, in my experience, there's no sort of silver bullet when it comes to carbon data. And so this chart is illustrating the different types of tools that we use at different moments in time. So this is uh, sort of the x-axis, if you will, is the project timeline. So we have the proposal and the concept phase, so the early phases on the left-hand side of the page. The center is the optimization phase, so SD and DD level, and then the documentation phase in CD level. And so the area of those curves are illustrating the sort of potential for impact over time. The blue is operational carbon, and then the green is embodied carbon. And those colors will repeat later on in the presentation, so make a mental note of that legend. Um, the tools that we like up front in the sort of early design phases are things that are really going to help impact change. So it's really important early on to being able to calculate carbon both from an operational and an embodied standpoint, so that we can help drive decision making. And so some of our favorite tools to do that are C-Scale, which is formerly Epic, and the CARE tool. And these are both open source tools online that everyone has access to. And you just plug in a few pieces of information about your project. You really don't have to know a whole lot about it in order to get information spit out. Um, both of them they're outside of those blue and green curves because they calculate both operational and embodied carbon. So you're getting a total carbon picture by using those tools. And it allows you to sort of twist the knobs and try out different combinations of things to see where you can optimize carbon. And so that's one that we use a lot in-house. And it's one that I really like from a carbon literacy perspective because it allows everybody to get their hands on it and just sort of experiment with the different ways to report out carbon there. So once we have all that data from those forms that I mentioned earlier, one of the key ways in which we use this information is through the AIA 2030 commitment. We're now on year 14 of reporting data to the 2030 commitment, and something we're really proud of and tracking data over time. One of the metrics associated with that we're really proud of is that we report embodied carbon on 100% of our projects. This is now the third year in a row that we've reported embodied carbon on all the projects submitted to the AIA. And that's been the trend since 2020. So we're really sort of ahead of the curve when it comes to reporting embodied carbon. It's not necessarily the norm when you look at the 2030 commitment numbers. And that's really because we rely on some of those early embodied carbon tools. And we hope to continue to report 100% of our projects in the future, and we continue to push that within the office. All right, so now I'm going to get into a couple case studies of um, existing building reuse in practice and how we use those carbon tools um, on those projects. So this first one is Slauson Middle School in Ann Arbor, Michigan, and we've been really excited about this opportunity to collaborate with Ann Arbor Public Schools. They are a client that is very driven by sustainability, and they came to us with a lot of sustainability goals. They didn't necessarily have a pathway. They didn't necessarily know what it is they were looking for, so it was a really good opportunity for us to collaborate with them to help develop a suite of tools and um, uh, throughout the course of the project, different stages of reporting as we went along. So this is sort of akin to that diagram I showed earlier with the different tools, but in practice. So early on in schematic design, we did a care tool analysis and showed them different ways that we could preserve different portions of the existing building and how much carbon we're avoiding through different building reuse schemes and sort of minimizing any demolition and new addition pieces. Along with that, there was an addition that was necessary, and I don't want to belittle the need for additional um, uh, new building construction because there's always a time and a place for that, right? And this was one where they needed a new gymnasium. So we evaluated the embodied carbon of the structure through a couple different schemes, including a cross-laminated timber roof and mass timber structure. Um, and there was a need for CMUs for the gymnasium, and we were able to provide alternative and lower carbon options for the CMUs as well. So that was sort of the SD level phase, was really evaluating whole scale design decisions. In the DD phase, we used Tally and Kaleidoscope to evaluate different envelope design options for addition and renovation pieces of the project. The big driver for this project was actually the insulation. Most of the school needed new insulation to meet um, uh, more stringent code since the original construction of the building, and just higher performing building for the operational performance goals for the project. Um, and in the CD phase, we did conduct a whole building lifecycle assessment, and that's again using Tally. So sort of a note on the envelope optimization. Um, we looked at a couple different options here. There are sort of six of them, and with the sort of resultant embodied carbon numbers, and there's such a huge range, right? The wood rain screen option is 25,000 kilograms of carbon compared to an insulated metal panel that was over 100,000 um, uh, kilograms of carbon equivalent. And so there are really great opportunities here to evaluate um, uh, small changes that can have a big impact when multiplied over the scale of a new building or a renovation scale. So um, back to the piece I mentioned earlier about insulation, that's what's really driving the difference in envelopes here. Um, so just to highlight a key decision that we helped the client to make for this project, looking at the insulated metal panel versus a custom metal panel assembly. From an aesthetic point of view, they're going to look very similar. Um, but we were able to switch out the type of insulation for a lower embodied carbon insulation material with a custom metal panel assembly um, compared to that insulated metal panel, the sort of prefab option, and avoid a fair amount of embodied carbon there. So this is just a little diagram illustrating the different strategies for carbon avoidance in this project. And based on some of those decisions that we made through the different phases of the project, we were able to reduce over half of the embodied carbon that would have been emitted with a new building and saved over 3,000 metric tons of carbon. So this project, a little bit closer to home for those of you in Virginia. This is the University of Richmond Humanities building on uh, in Richmond, and this is a renovation and an addition to Ryland Hall, which integrates a modern classroom and office needs into the framework of this historic building. The play between new and old is really key to the success of this project. And this is another client that's really driven by sustainability, and they're really sort of walking the walk, if you will. All new buildings constructed on campus are required to achieve LEED Silver status or an equivalent rating. And these LEED requirements influence the design, building, and maintenance of buildings to provide a safe and healthy workspace while minimizing the impact on land, air, and water. So the environmental, social, and economic conditions that foster health and well-being for people in the natural world now and for generations to come. And I just think that's such a great message, especially in a campus environment. So these are some images of the space after the construction was completed. The renovation and additive space is such an obvious benefit to students and teachers. It really improves the function and informal gathering for study, and also a greatly improved indoor environmental quality. The greater community um, is able to see the sort of new interpretive exhibits throughout the project. Um, and this project, when completed, was the university's second Earthcraft certified building and the, I believe, 17th certified green building on campus. So we love to see it. Um, and now to put the carbon into context, based on the amount of carbon that was avoided through building reuse, nearly 70% of the project mass is existing building material. So 1,300 metric tons of avoided carbon, which is roughly 5 times the area of the University of Richmond campus. If you were able to translate this to the amount of carbon that is sequestered from trees in acreage, that's how much land you would be talking about. And that's just one building, right? Um, so the impact that one building can have is actually quite great when you look at it in this context. Okay, and another example of existing building reuse. So this is the Plaza building in Detroit, Michigan. This was a previously vacant building, originally built in the 60s in the international style. It's this sort of iconic high-rise building located right in the heart of Detroit's Midtown district. As part of the renovation, it was adapted into a mixed-use residential development. So part of our job on the project was to research and document the building to list it on the National Register of Historic Places and support the project's eligibility for state and federal historic tax credits, which we were successful in doing. We created 72 units, including 2 large penthouse units in the building. The exterior curtain wall was restored with new glazing, which was necessary for the performance of the building. So I want to demonstrate here the value of reuse for this particular building. And this was an analysis done using the CARE tool that I cited earlier. So we have a couple options here. The baseline case is if you left the building as is and didn't improve the operational efficiency of the building. We know that's not really reality because it was sort of a vacant building, but you can sort of extrapolate the information there. Um, Option 1 is to retrofit the existing building with a 30% EUI savings. So if you somewhat improve the operational efficiency of the building while retrofitting it and leaving most of the building in place. Option 2 is a similar scenario, but making it a little bit more high performing, so 70% EUI savings. And then finally, the third option is what if we demolished it and built new in its place with a higher performing building, so that's 70% EUI. So the reason these bars are all super low, this is just after 1 year of operations. Again, embodied carbon is the green and the blue is operational emissions. So very obviously, option 3 has the most carbon emissions up front because that's the high embodied carbon emissions associated with a new construction. So now, looking at this over the course of 20 years, so the combined carbon of each year of operations from day 1 until year 20, it's looking like a very different story here, right? Where on the previous slide, it might have looked like, okay, let's just like not touch the existing building and leave it in place. Well, if we continue to let it operate at a low efficiency, it's going to add up over time very quickly compared to the other options. In this case, the option 1 with the retrofit option is looking pretty close to the option 3 with demolishing and building new. But the sort of sweet spot here is that you need to not only renovate buildings, but also work on their operational efficiency at the same time. So we can't look at either embodied carbon or operational carbon in isolation. They really have to work in tandem if we're going to be talking about sustainable renovations of existing buildings. And I have a similar story to tell here with Old City Hall. This is another Richmond project, and um, it's actually featured on this webinar series, the sort of promotional imagery. This is another historic property that Quinn Evans worked on for many years and was completed last year. Um, it was first opened in 1894 and last renovated in the early 1980s. Um, and it's a neo-Gothic natural historic landmark. It was first considered for demolition in 1915 when the Gothic revival wasn't really in fashion anymore. And it was threatened again in the 1970s when the city government moved to a new building. But the state purchased it and pledged to preserve the building in 1981. So if we use that same sort of order of operations as we saw in the Plaza building, baseline case on the left, sort of our do nothing. Option 1 is I've sort of flipped these around now. Option 1 is your demolish and build new. So a high chunk of embodied carbon there to replace all the existing building. Option 2, demolish, build new, higher performance. And then 3 is a renovation with 30% savings. Uh, so once again, like we're seeing that the renovation is going to be the better thing over time compared to demolishing and building new. In this case, there were some limitations to the building from a performance perspective, and we'd like to see those EUI savings to go up, and I think that's something that's going to only continue to improve over time. But from an embodied carbon perspective, I think it's helpful to put this into context again, just to think about the amount of material that stays in these existing buildings by not demolishing them. Um, the amount of granite and bricks and iron, the miles and miles of tubes and wires and things that remain in the existing buildings that would otherwise be, um, generally sent to landfills are things that we can preserve in place, and that's that's sort of our objective here at Quinn Evans. Um, So again, focusing on embodied carbon, this is a little diagram illustrating. So the center circle, the dark green, is the embodied carbon that is created with a renovation. So in this case, the example is Michigan Central Station. So all of the embodied carbon that goes into the materials associated with the renovation is that center, the 1,700 metric tons of carbon. The larger circle is the amount of carbon that was avoided through reuse. Um, so nearly 16,000 metric tons of carbon are avoided by leaving the existing building in place. So now to put that into the context of this is the entire Quinn Evans portfolio from just the last 4 years. When we start to think about all these renovation projects that we do, it really starts to add up. Um, and let's see which one is, I think Old City Hall is on here too. Um, I think that's like this little one down here, and that's a pretty large building, right? So um, we have a lot of opportunities as architects to impact change, and existing building reuse is one of the ways in which we do that. And again, to put that into context, to make embodied carbon something a little more tangible, um, within the past 4 years, we've avoided over 200,000 tons of carbon emissions, which is, the equivalent of taking roughly 50,000 cars off the road for a year, and powering 40,000 homes on average for 1 year. And this is just projects within the past 4 years. And Quinn Evans has now been in operation for 40 years. So there's a lot of data that we're not even capturing from previous project work. And, um, thinking about project work that we'll be doing into the future, there's a huge opportunity here for us to be sustainability champions through the use of existing buildings and renovation work. Okay, so now that we've established how to make the case for existing buildings, we really have to figure out how to make them work for us in a number of ways. So I cited earlier that, sometimes there are limitations to existing buildings and their performance may not equal that of a new build, but we're starting to think about ways in which we can make renovation work just as efficient as or as a new construction project. One of the big limitations that we see in this world is daylighting. So daylighting in existing buildings can often be a really tricky thing if you're dealing with envelopes with limited window to wall ratio. Perhaps you have historic windows that are smaller punched openings and you're not getting great access to daylight. Maybe there's footprint limitations to the existing building plate. So one of the things that we sought to explore is how to improve or how to evaluate daylighting in existing buildings. This was we were awarded a AIA Upjohn research grant, and in partnership with the University of Oregon, we evaluated circadian health via daylighting design in existing buildings. And we developed a report and a graphic guide. If you are so inclined, the QR code will take you to our website where you can access this information if you want to learn more about what this means. I'll try to give you the cliff notes because it gets really technical really fast. But circadian health is the sort of non-visual impacts of daylighting on human health. Um, you've probably heard people talking about blue light in the evenings and how we're not supposed to look at screens before we go to bed. Well, it's related to that. So we need more daylighting during daytime hours to entrain our circadian system to impact things like hormone health and um, your cycle of sleep and helping you to stay awake and alert during the daytime hours and sleepy when you're supposed to be sleepy. And that all has to deal with daylighting exposure, so circadian health. In our research, we were really interested in the lens of existing buildings. So we evaluated different design opportunities that existing buildings have or maybe don't have if there are limitations with existing building design, and evaluated them from the different impacts that they can have on your circadian health. So we actually used Old City Hall as a case study for this research work because we knew that there were sort of limitations to the design of the building. Because it was a historic building, we can't really touch or adjust the facade. We can't go punching larger windows in a historic building. So what are other opportunities that we have for improving circadian health in a space like this? Well, one of the ways to do that is through careful selection of finishes and raising ceilings, adjusting interior partitions and things so as to let light get deeper into a space. So on the right-hand side, you're seeing the sort of after image. And what we found um, in the research was that having bright colored reflective finishes is actually one of the biggest drivers to improving circadian health for occupants within the space. And so, good news for this project, that was we were able to improve the circadian metrics by almost or a little more than double in this case, just through some of those interior fit out changes. So we were really excited about this as a resultant for the case for existing buildings that you don't really have to do a whole lot and you can get a lot of bang for your buck by just doing things like selecting brighter and more reflective finishes. So again, if you have more questions on that sort of research, look at that QR code and check that out on our website. And I'm happy to speak to that more because I'm giving you just the very high level of that. Um, and then one other tool that we're thinking about with regards to carbon and existing building renovations is digital twin technology. This is something that we're working hard on here at Quinn Evans. We see a great opportunity for this within our sort of practice of existing building renovation work. So HBIM work is something that's been around our office for a long time. And now we're starting to see these suite of tools develop for live tracking of building performance. So if you're not familiar with what a digital twin is, it's basically kind of like having a Revit model of a building that in real time you can go in and look at different pieces and parts of the building. On the screen here, it's showing uh, think it's temperature or relative humidity, but basically you're tracking environmental conditions in real time. And it allows, say, the owner of the building to look at a space and say, hey, that one looks like it's the humidity is really high. Maybe we should go figure out what's going on in that space. And it allows a higher level of control of environmental conditions. But one of the other things that this allows you to do is to integrate information about physical elements within the building space. So we've seen use cases for this in historic properties where you're sort of tagging, um, let's see, like floor tiles, and you can isolate the individual elements of the space and say, okay, the last time that this was serviced was 6 months ago. We should get somebody out there and look at that now. Um, So just to bring this back to carbon and in the case for existing building for use, what I see a real value for here and something we're starting to develop is um, also with this digital twin technology, you can isolate all those components of the project and sort of group them together and take stock of your building. Well, hey, that looks a whole lot like that image that I showed on the screen earlier, where you can lay out, piece by piece of a building and start to calculate carbon for individual elements. And if we can start to use that technology to introduce the carbon accounting metrics, well, there are tons of opportunities there for evaluating the existing building reuse metrics as associated with embodied carbon. So that's just like another tool that's coming to fruition, hopefully, and we'll continue to advance that research as we go. All right, so just to close this out today, I wanted to leave you with a couple take home items and how to take action when it comes to carbon. So the first is you can't manage what you don't measure. So if you're not already evaluating carbon, both operational and embodied on your projects, start today. I listed out a couple tools that are great entry level opportunities for doing that. Um, so that's sort of the first one. The second is to think about carbon holistically. Those bar chart examples from earlier were really to illustrate that it's not just about embodied carbon and that's not just about operational carbon. You really have to think about both pieces together. If we're going to talk about sustainability, we really have to be evaluating both in tandem. And then finally, steward existing places. I think I've kind of made the case today that the greenest building is the one that's already built, but it does require careful stewardship, and that's our job as architects to improve those buildings and steward them into the next generation. So with that, that concludes my presentation, and I think we'll open it up for Q&A.
Thank you so much. I thought that was a incredible presentation. I think you really articulated very clearly and simply something that's otherwise pretty mysterious to many of us. So thank you so much. Um, Jumping into one, we got one question in Q&A, and I know I jotted down a bunch while I was listening and a bunch before the presentation, but it's not about me. So Katie had asked, I think it's specific to your plaza building example. What are the difference in the systems between your 30% EUI savings and your 70% EUI savings?
Oh,
There's specific things that were being explored there that
mm.
really made the delta.
You know, I'm not as familiar with that project, so I can't speak to that personally. Yeah, for that plaza building example, I'm not sure. Usually it looks like, we're evaluating different system types, like whether that's a heat pump versus sort of your sort of more standard technology. Are you implementing things like geothermal systems, or it could even be like lighting design, right? Like high performance LEDs versus sort of your old school. Um, yeah, I don't. Sorry, Katie, I can't speak to that one. I need a plaza building expert for to speak to those differences there. And we may not have actually evaluated the system differences. I think part of that, again, like with those early tools, is um, somewhat speculative, and just yeah, trying different things out.
I know with a lot of our work, our clients are often asking, what's the difference between the systems in terms of performance, and what should we expect in terms of operations over time? And we're often comparing the geothermal coupled with a water source heat pump versus a more traditional like a VAP type methodology. So I certainly don't know that project either, but I know it's a pretty common question, and I think we're being asked more and more often to help them understand that, because even if we're salvaging, um, you know, most if or even all of a building, we're often finding ourselves having to shift out mechanical equipment, and so there's a great opportunity there.
Hmm. Yeah, and that's one where you really want to leverage the use of your engineers too in doing a life cycle cost analysis because sometimes if there's like a slightly higher upfront cost, that may come out in a wash if you look over the 10-year, 20-year lifespan of that equipment. So, yeah.
Absolutely. Um, Noah commented, great presentation. Thank you so much. So
Thanks, Noah.
thanks. Yeah. Um, I love that AIA slide that shows the percentage of billings versus existing. It shows the existing building work steadily increasing, and I know in my practice, I definitely experienced that. I've kind of gotten to be known for doing a lot of existing building rehab work or additions to existing buildings with renovations. What percentage of your work or Quinn Evans' work would you ballpark? Um, and well, maybe a different question. Is the firm trending in that way, aligning with that AIA trajectory?
Um, yeah, it's a tough question. I don't know the numbers. Um, but I'd say since we've sort of we've been sort of experts in the building reuse world for a while. So we've actually sort of positioned ourselves to take on a greater share of that work initially. So I think in some ways our numbers are going to be skewed, but we do continue to see more and more renovation work coming on our plates. So um, yeah, certainly more than half of our work is renovation work.
Yeah, and I mean, probably 90%, maybe 95% of mine personally
Mm,
as a principal is renovation work or an addition and alteration to an existing building.
mm.
Um,
Has it trended in that way to flip the question onto you? Has it trended that way in your experience?
um, yeah, I think it has, I'm not sure if it's just geographic for where we are, um, or if it's the climate of cost control strategy to say, hey, how much of this thing can I save? I don't know exactly what's driving it. It's probably a combination of all those things and many more. But yes, I think it's trended more towards existing building reuse renovation. Um, do you see Quinn Evans um, seeking out more of this type of renovation and adaptive reuse work, um, especially as it relates to like carbon accounting?
Yeah, um, I think so. I think it's sort of one of those things that if we see it come up in an RFP, it's sort of like, oh, that's great. Like we love to see clients asking for that kind of work, and because we have the expertise and the in-house ability to do that kind of work, that is something that if we see it, it's sort of in the pro list of, pursuing that kind of work.
Yeah, not sure. I don't see any more popping up in the Q&A, but I'd certainly encourage everybody to kind of chime in if they've got something that they want to hear more about. Um, let's say, for example, I'm not well versed in carbon accounting, um, and I've got to get up to speed, but it's going to take me a little bit of time. What would you say I could decide to do on a project today that would have some of the biggest potential impact? Or let's say I never get up to speed on it. Where would what would be some of like the kind of baseline best decisions that I can make to influence carbon reduction?
Mm. Yeah, I mean, preserve as much of the existing building as you can. That's uh that's generally the first place. Within reason, of course. Like and we see a lot of this where there are certainly plenty of reasons that you would need to demolish an existing building and replace it in kind. Like the Neville Thomas example I showed earlier, there is an existing wing to the project that we had to demolish and replace with the addition, and that's due to the fact that that portion of the building was structurally failing. It's in a floodplain, so we had to raise up the first floor. There are lots of reasons for that. So, um, you know, you have to take those accounts into consideration when you're thinking about existing building reuse. And when I say like save as much as you can, that's, within reason, of course. Um, and then, beyond that, um, That's why we like to do the early carbon analysis is so that you can identify the sort of hot spot of like where the greatest potential impact for reduction there might be. So um, there's a list of, I think, like a dozen of the highest embodied carbon emitting materials, and you can find that pretty easily. It's, no brainers, like it's going to be the carbon, the steel, the glass, like all this sort of heavy materials, typically structural elements are going to be the biggest emitters. Um, but then there's some sneaky things like some of the like precious minerals, or if you're using like exotic woods or things like that, those are going to be bad from an embodied carbon perspective. Um, so those are um, some of the places you can look. Just sort of the typically, materials that we know to be higher emitting materials without even having to do an analysis of your building itself. So
Are you seeing more carbon um, spent, for lack of a better term, on the fabrication of the material, or is it the um, transportation of the material, or like where does the majority of that
mm,
energy, exist?
yeah, that's kind of an it seems counterintuitive. A lot of people think that transportation is like really bad. Like I think we've heard a lot of people saying like, get the hyper local stuff. You want things within like a, 100 square mile radius of your project. But in a lot of cases, that's not really what we see in the data. It's really the fabrication of the material is going to be the largest emitter. And so when we look at like lead documentation for LCA, or whole building life cycle assessments, they're usually looking at the like cradle to gate operations. So the phase A, if you're looking at an LCA, and that's kind of technical jargon, um, because that's typically where the most carbon is just in the fabrication of material. It usually outnumbers the transportation emissions by a lot. So, and that kind of comes down to just the production of the
Interesting.
material. So, a good example of this would be like, I don't know, you want to get something that's hyper local to your project, um, and the plant that can make it isn't as efficient as something, say, out in Seattle, and you have to cart it across the country. But the Seattle factory might use, I don't know, better, or they might have a cleaner grid where they're assembling the materials, so there's less carbon emissions associated with the fabrication of the material. Um, so there's, yeah, lots of lenses by which to look at that.
Cool. We've got two questions. Katie's chiming in here. Thank you. For Slauson Middle School, what was the decision on the gymnasium envelope? And what was the highest priority when you made that decision?
Yeah, I'm trying to think of where it landed because that one was there was a lot of back and forth. Originally it was going to be all mass timber, and then it was going to be, I believe, a brick facade on the CMU backup. Um, what I think we landed on, so there's still a CLT roof. I think we had to go away from the mass timber structure, like the columns and beams, but the roof itself is still mass timber. Um, and then we are hopefully still going to get the low CMU um, uh, blocks for the wall. Um, that's a little bit of a tricky one because the it's called, I think, carbocrete is the product, but it comes out of Canada, so that might be a bit of an issue in this climate. Um, but it was something that the latest that I saw is still in the project. So
Cool. Um, Sarah's got one for us too. When we're adding solar to projects, are you incorporating battery storage? I guess
Mm,
that's part one. And then part two is how are the environmental impacts of that factored in?
yeah, that that's a good question. I typically don't see battery storage. I think that's less common. Usually, the solar installations that I've seen are just feeding that power back to the grid. Um, yeah, the batteries are, yeah, talk about embodied carbon. Those precious metals and things that go into batteries are kind of a doozy when it comes to embodied carbon, but um, not always necessary for projects. Um, and environmental impacts of the manufacturer. Yeah. That's one where you kind of need to do the carbon accounting to understand the sort of trade-offs and how many years of clean energy it takes to offset the production of the solar panels themselves. Um, but that's, generally we're talking about a long game here from an architecture perspective and um, um, yeah, I don't know and it probably varies widely, the amount of time that it would take to offset that, the production of the solar panels themselves. Um, but again, if we're thinking in like the 10, 20-year carbon emissions, there's probably going to be the offset over time. I don't know if that answers your question.
I
It
know I'm not,
depends.
yeah, yeah, I'm not an expert in solar and connecting back to the grid versus battery storage and things like that. I'm sure there's probably some other reasons, and maybe it's resiliency or things like that, why you may choose to have batteries on site.
Hmm.
But I think we could probably have a whole presentation on the pros and cons of that decision.
Oh yeah.
But I do think that there's a lot of benefits of connecting to the grid, and if you're not using the energy, you can kind of give it back as a clean version. So
Hmm.
uh, I'm curious to know what innovations in materials. I clipped this building and construction CO2 emissions by type from your materials, and interesting to see structure as like tops. Certainly, when I see structure, I'm like, oh, we're definitely going to use some concrete, we're definitely going to use some masonry, and we're definitely going to use some steel. In most projects,
Hmm.
it's hard to get away from. There, you can easily access them just about anywhere in the U.S. And but what innovations are you seeing that you're most optimistic or excited about? Like I've read about like growing concrete blocks out of coral and like these things that are, maybe not quite as realistic, but what are you optimistic about that maybe has a real potential to become a mainstream product that really is a game changer? Like we saw LEDs shift. If you've been
Hmm.
around long enough, you saw fluorescence fade out in LEDs and there was an initial cost. But then, I mean, now everything's LED and it's totally changed the game. It's more energy efficient and the light quality is better. So that's a long-winded question, but
Yeah.
what's got you pumped?
Personally, I'm like super amped about CLT and the mass timber industry. I just think there's so much opportunity there, and there's been so much more uptick in that on the West Coast. I think the East Coast is slowly playing catch up, but we're starting to see a lot more projects asking for it and at least attempting to make use of CLT and other heavy timber products. Um, it's been proven in the different sort of regulatory environments. It meets fire code. There's, ways of getting around the sort of acoustics and vibration issues. Um, so we've developed the sort of the research to support it as a product. So, I mean, that's the one that I'm probably most jazzed about because the trees are sequestering carbon during their growth period. And then once you sequester that carbon, then you put them in the building. So it actually, if you're using responsibly managed forest, you're actually extracting carbon out of the atmosphere before putting the product in your building. Um, so I think that's probably my favorite thing. And it's, not a wild out there thing. It's already accessible and it's an option. Um, and there are tons of new technologies with carbon. Those like the low carbon CMUs are a cool one that I'd like to see implemented more because that is a product that we're going to see in most every project in some capacity. Um, and what else? I guess those are the big ones. I'd like to see advances in, all of the sort of product lines, but that the structural ones are the big ones.
Cool. Um, I'm gonna keep going unless anybody has something. In your time value of carbon graph, we started with the existing building do nothing on a 45 degree, and I understand it's illustrative. But at some point, like we're still carbon. I don't know if the term's carbon positive, right? We're still have some carbon. So what do we do then to offset? No matter what we're doing as architects, we're building, we're spending energy. So at the end of the day, we can minimize that through this process, but we're going to have at least some that's invested in building this building or renovating this building. So then what do we do? Is it as simple as like plant trees, or where do we go from there?
Yeah, that's where we do really have to look outside the building envelope. Um, our job is to do the least amount of harm, drop that number down. It's like way easier to offset a small amount of carbon than a large amount of carbon because if we keep going business as usual with that 45-degree slope, there's no way we can offset that. And there's, speaking of novel technologies and things, there's these like crazy carbon capture machines and all sorts of stuff out there, but we really can't keep up with the current emissions rate. It's just crazy. So yeah, the first step is to just reduce that as much as possible. And then, yeah, eventually we are going to have to offset it with other things. And um, that's where we really want these not just net zero buildings, but net positive. Um, and I think we have to think about that beyond, again, just not just beyond the building envelope, but sort of um, the proportional way that we're looking at this. So, um, for instance, like when we're talking about net zero buildings, it's on an annual basis. Um, it's not that your building's always going to be producing more building than it's emitting. There's going to be points in time where it's higher and sometimes where it's lower, and you're sort of offsetting those things. And if we can achieve that sort of balance at grid scale, city scale, that's really what we want to do. So the not every building is operating in isolation. You really have to think about how everything's sort of interconnected, and um, the balance is, hopefully going to tip in the right direction, but we have to sort of get everything, closer to that sort of tipping point in order to really offset what we do produce.
Are we gonna, maybe we already have, start to see carbon banks like we have stormwater credits? Like, is that already a conversation, or will we see that as a conversation?
Well, that is an interesting conversation. I don't know so much about that, and I'm not an expert in the renewable energy world, but I do think of like community-based solar programs, right, where um, everybody's sort of helping fund solar for like a neighborhood or something like that. Um, yeah, I mean, I'd love to see that. I think that's a great idea.
Take it and run. Um, we still got a couple folks hanging on, listening in. I'll throw out another one. How if it's my rookie season in carbon accounting, like where do I start?
Yeah. Yeah, start with some of those early carbon tools. The ones that I reference all the time are um, C-scale. I always want to say Epic. It's C-scale now. And the Care tool. Those are my two favorites. And Care is an acronym. It stands for Carbon Avoided Reuse Estimator. I think I got that right. Um, So it's really poised to help understand the value of existing building reuse. So that's probably the one that's most relevant for that as a use case. Um, C scale kind of can run the gamut of a lot of different design iterations, and it's yeah, they're both just really super easy tools. They only take 5, 10 minutes if you know everything that you need for the inputs of your building. Um, and they're very user friendly. So start there.
Sounds great. Sarah, Katie, any questions that you've got for Denise while we've got her? Hearing none. Well, Denise, I'm going to thank you for your time, your energy, and expertise here. I appreciate it. I thought the conversation was fantastic, and like I said before, really helped to simplify a lot of it. So I'll turn it back to Delaney if she's got any closing
Yeah.
remarks. And thanks again.
Thank you.
Great. Thank you so much, Andrew, and thank you, Denise, for being with us today. No big closing remarks. Just want to say thank you to everyone that's been on the webinar for the series, and we really appreciate your participation. So, hope everyone has a great rest of your day. Take care. Bye bye.